Hi, fifth grade. Welcome to your new lecture. Let's go ahead and get started. If you haven't pulled up the PowerPoint slides yet, go ahead and do that. It's the Earth's crust. That's the title. So your warm-up says, what is the outermost layer of the Earth called? It's the part that we're on. A hint that it's the title of this lecture. And if you need further help, you can look in your book. But the answer is, drumroll, the crust. Hence the title of our lecture today, The Earth's Crust, Chapter 10, pages 106 to 107. Okay? So if you flip to slide 3, you'll see a little diagram there. It's the layers of the Earth. So the Earth itself, the planet, has multiple layers. The very outer layer, the most outside part of it, is called the crust. That's the part we're on. Inside of that is called the mantle. The mantle's pretty thick. Then the outer core and the inner core is all the way on the inside. So the core is the whole center. The inner core is the very, very center of it. Lots of different things are in these different dirts, different metals, there's magma in there, like in volcanoes, all that kind of stuff. Gases, everything like that. So if you flip to slide 4, there's something called the lithosphere. In the lithosphere, you'll see that I blacked out most of the mantle, the outer and inner core, because the lithosphere is just the crust and the upper portion of the mantle, just a little bit of it. That's the whole lithosphere, and the lithosphere is what we're going to be focusing on today. So if you flip to slide 5, you'll see Pangaea and the continental drift theory. So there is a theory that back when the Earth was first formed, that all of the land we know today was just one giant landmass. You can see in the picture there, it's the green. You can kind of see the shapes of North America, South America, Africa, all that in there. And it was all one giant mass, like the dinosaurs all lived on it together. And over time, it all separated into what we know today over many, many years. Those pieces of land are called tectonic plates, and they're literally just like a piece of land sitting there. And over time, they pushed away from each other. And they made what we know as the shapes of our land today. These are, again, all these tectonic plates are what makes up the lithosphere, okay? So, next slide called plate boundaries. If you think about all these pieces of land, so I know you know the Earth is covered in mostly water, the oceans. There's land below that, right? There's the seafloor. So those are tectonic plates as well. They all just line up to each other to make the big sphere of the Earth. The land we stand on is just a bit more raised. It pops out of the water like an island. So on these tectonic plates, they all line up together like puzzle pieces, and those lines where they all line up, they're called plate boundaries. They're borders that, kind of like the borders of states or countries, they just fit together all nicely in a puzzle, and they define one space from another, like how the North Carolina-South Carolina border defines each state from the other one. So there are 3 kinds of these borders. 3. Convergent, divergent, and transform. They're responsible for making new pieces of land, like islands. They can make volcanoes, they can make trenches, all different kinds of things along this Earth are made by these tectonic plates, and their boundaries coming together, pulling apart, all that kind of stuff. So the first one we'll look at are convergent boundaries. To converge means to come together. So these plates, they're all kind of just floating on top of the mantle, all right? And over time, constantly, they're slightly moving. And every once in a while, they collide, they come together. And as you see in the picture there, in this example, some mountains are being formed because here's our 2 plates. They're floating next to each other. They're just touching. And then over a while, they start to move closer and closer together, and one goes under the other. Okay? So the land that's on top is the mountain, it makes the mountain. and the other stuff just gets recycled back down into the mantle. As the slide says, it can form mountains both on the land and in the ocean. It might not pop out of the ocean, might not be tall enough, but it'll create a whole ridge in the ocean. Or it can create ocean trenches. If you've ever seen Finding Nemo, when they have to either go through the trench or go above it and go through the jellyfish, that's a trench, the big deep thing. These can form those. And the last thing it talks about on the slide is that these boundaries tend to recycle old crust and new crust. So new crust is deeper into the layers of the earth. It's just being formed. Old crust is what you stand on. And when one plate goes over the other or whatever it's doing, anything that goes down is getting recycled and turned into new crust. It'll get broken down and melted all down and form new rock. And the stuff that's on top is older. Okay. Our next one is divergent boundaries. So convergent meant to come together. Divergent means to separate. Pretty simple. So when two plates pull apart, the magma fills up the gap and cools, forming new crust. So remember that you've learned about magma before. It kind of just exists in the earth. It's what lava is before lava comes out of a volcano. It's molten, really hot, just kind of melted down rock and everything like that. So when these two plates pull apart, so let's say they're together like this, and they pull apart, and there's a gap here. Instead of the gap just staying like that and going all the way down, magma will well up, fill it up to a certain point, maybe all the way, maybe more, who knows, and it forms a new crust, because remember, it's coming from the underneath, it's being recycled from bottom to top. So these boundaries can form a rift on the continent. Maybe there's just like, it pulled apart some and there's a big old trench sort of thing. Ocean ridges and volcanoes are the most common. Volcanoes, you know, the magma will well up and just wait there until it erupts one day. All right. Our last form of boundary is a transform boundary. And so we talked about coming together and moving apart, but they can also move side to side. They can kind of shuffle like this, just move against each other. So these are where they slide past each other. They don't really move together or apart. They kind of just slide past each other, like how cars go the opposite ways on highways, like that. They're constantly moving again, and usually this just results in small cracks among the land, but transform boundaries can cause big things like earthquakes. This is because when it forms these small cracks over and over and over again, they're called faults, and these faults can be very dangerous because if they get bigger, the land will just pull apart and be very dangerous and have an earthquake, blah, 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 blah. So one of the best known transform boundaries, you've probably heard of it before, is called the San Andreas Fault in California. It's very, very active. It's a whole line along the Californian coast that there's just a lot of seismic activity there. The plates are constantly shuffling against each other, constantly causing these small cracks and lots of earthquakes. There's so many theories that what happens one day if there's a huge earthquake. Will the land completely split apart? Who knows? We can't really predict that, but maybe one day we'll see it, maybe we won't. So that's all the information about the plate tectonics and the boundaries you need to know for today. The last slide does have your homework. So imagine if there was a convergent boundary when they come together from the one town to the other that we know, and what would happen if the plates moved? Describe how the plates would move, so what direction would they go, and what would happen to the land? What do you think would be formed? Okay? Bye!